stands for corresponding parts of congruent triangles are congruent. Course CPCTC. It's just an abbreviation. LN bisects an angle KLM. And you're also given that angle A is congruent to angle M. Please mark that in the picture that K is congruent to M. Whoop. It splits up this top angle into two little angles. So like Logan said, label it and then mark them congruent because they should be the same. And then write that down in your proof, that 1's congruent to 2 because you have an angle bisector. Definition of angle bisector. Great. If we want to prove these triangles congruent, you need another piece of information. Liberty, what's another thing that I can say is congruent right now? Yep, LN. When we have a shared side, we call that reflexive. Mark it in your picture. You don't get a medal for trying to do it in your head. Just mark it. If you look at your picture now, you should be able to tell me that these triangles are congruent. Tell people at your table which theorem you should use. Which of those 5 over there in green? You should be using angle, angle, side, because that side is not between the two angles. It's not included. So AAS. So you're going to say for me, ooh, you got to use the right order. If you say LKN, then you have to be careful in how you choose the order of the other one. If you do LKN, it's congruent to which triangle? Have to go in the same order. LMN. That matters. Okay. And this is because of angle, angle, side. Here's the thing. That's not what you're trying to prove. Look at your proof. It asks you to prove that KL is congruent to LM. You're not done. You say, and I ran out of room, my bad. KL is congruent to LM. Your reason is because of CPCTC. Here's what I need you to notice. You have to say that triangles are congruent before you use this, because it functions on the fact that you have congruent triangles, and so all of the other stuff is the same. So I don't want you to tell me, like if you have a proof like this, when we're proving triangles congruent, always get the triangles congruent first and then use CPCTC. You're going to end with that. You have these segments, they're bisecting each other. Please discuss with your table or just mark it. What's congruent then? Okay, Cole, can you give me a pair of segments that's the same? Yep, these guys, mark it. John, can you give me another?
YZ.
Yes. Notice I marked them differently. You don't note that they're all congruent. So now say those both because they're bisecting each other. YZ is congruent to PZ. Oops. And XZ to QZ. Why? Definition of a segment bisector. You can get a freebie from the picture. Allison, what can I get just by looking at the picture? Mark it. If you want to column 1 and 2, you got to label it. Write it. Okay, let's say that the triangles are congruent now. Triangle. X, Y, Z. Be careful when you name them because you need to name it correctly. X, Y, Z is congruent to what corresponds to X? Q. So it has to be Q, P, Z. Because, look at your picture, which one of these theorems are we going to use? You're not sure, mark it in. Which one? Aaliyah, what should we use? Side, angle, side. Look at your theorem, please. Or sorry, look at your proof. You are asked to actually prove, though, that X is congruent to Q. So you're not done. Why is X congruent to Q? Can someone put that in normal person language? What does that mean? Why is X congruent to Q?
Corresponding parts of congruent
Without,
angles are congruent.
yes, but like in a way, yes, I know you're saying what you're correct. All the things correct. Now you can say that these are congruent because corresponding parts are congruent. Angle X congruent to angle Q because of CPCTC. You are given that you've got some stuff that's perpendicular. You also have a midpoint. So lots of givens. Let's start with perpendicular. If XY is perpendicular to YZ, that would give you a right angle right here. I would go ahead and write it in. I would draw it in now. You also have that ZP is perpendicular to PQ right here. If you want to say that, like you have to say that in your proof, so you could call them angle 1 and angle 2. Ethan, what should I say in my proof then? About 1 and 2? Not yet. What did I say before that? We're going to say that eventually. Look what we just marked in the picture. What are they? They're right angles. You got to say that first. Angle 1 and angle 2 are right angles. If you look at your gold sheet, that's what we have written down. When you're given that things are perpendicular, you should say that you have right angles because of the definition of perpendicular. Now, you can say they're congruent. That angle 1 is congruent to angle 2. Ooh, we did this yesterday. So your reason, right angles, congruence, theorem. Great. We still only have one angle right now. We got to get some more things. Suggestions. What should I say next? Vertical angles. Sounds good. Let's do that. If you want to label those in your picture with numbers, you have to number them differently, like 3 and 4. So that's a freebie from the picture. And then you had one more given that you need to use, that you have a midpoint. So Alyssa, what's congruent with that? X, Z, Z, Q. Yeah. Is it XE? Which one's it midpoint of? It's the midpoint of Y, P.
So Y, Z, P.
Yeah, Y, Z. And then I'm going to do P, Z, but same thing. Those are congruent because the definition of a midpoint. Mark it in your picture so you can see it. Now you can prove the triangle's congruent, and then you can say that corresponding parts are the same. Look at your picture. Which theorem should we use? Cole, what do you think? To say that the triangles are congruent, we use which one?
ASA.
ASA. Okay, so triangle, we just did this, XYZ is congruent to, you have to say QPZ. Because of angle, side angle. And now, that last step, to say that the parts are congruent, you use CPCTC. Now you're done. In order to use CPCTC, you have to say beforehand that you have triangles congruent. Once you say triangles are congruent, then you can use it. I don't want to see you use CPCTC unless you have said triangles congruent.